holes. I think you might have done all this, right? So all the inventions which you see, that the Intel Pentium 4 processor or all the chips, all are based on the improvisations in semiconductors. So see, the metals and the doping is a very important concept when it comes to all these things, because you have to always find effective dopants. So the more the effective the dopants are, the more better the semiconductors which you can get, and all the chips of Intel which you are getting are based on these principles only. Anyways, for example, if they can give you a question of NaCl which is doped with CaCl2, what does it imply? I have a crystal in which I have sodium, I have chlorine, sodium, I have chlorine, sodium, chlorine, sodium, chlorine, sodium. Now if it is doped with CaCl2, what is the case? So for each CaCl2, I am having one cationic vacancy created. So I am writing, this is one cationic vacancy per Ca2 plus. For each Ca2 plus, there will be one cationic vacancy generated. Are we clear? So there are some questions in your booklet based on this concept. So now you can simply do it. Clear?
So there is a question, number of octahedral voids per atom in a crystal lattice of closed pattern.
The answer is wrong. Plus it's a crystal lattice, so if you take it to be CCP, number of octahedral voids will be 4. But they have asked you number of octahedral voids per atom. So it will be 4 by 4, which is 1. Number of octahedral voids are 4, but the number of atoms are also 4. So number of octahedral voids per atom will be 1. Clear? See, होता क्या है काफी बार what you do is in a lot of cases if you want to find out something known as the spacing between the two planes, which is known as the interplanar spacing. So what is D? So what you do is you find out a path difference. Okay. So what you have to do is n lambda equal to 2 into d into sine theta. N is known as order of diffraction, which can be 1, 2, something. Lambda is the wavelength and theta is the angle of incidence. So see, you know the angle of incidence theta, you know the wavelength of the light which you are using, and see, this is the concept of when you have done YDAC, young double slit experiment?
No, not yet.
Okay, so once you will do it, you will come to know that you have all the constructive interferences at n lambda. This 2d sine theta is nothing but this path difference. So this path difference is equal to n lambda for maximas. So I will have all the fringes at n lambda, and n is known as the order of diffraction. So if n is given to you as 1, if the order is given to you as 1, then n equal to 1. If order of the diffraction is 2, then n equal to 2. So all these are maximas which you are getting. This you will cover in more detail when you will study YDAC and diffraction in physics. This is a whole concept based on physics only. That's why for chemistry, this is 2d times theta is nothing but the path difference. And this path difference equal to maxima at n lambda. And why I am writing it as this? Because see, whenever there is a constructive interference of two waves, this is based on the diffraction of waves. So whenever there is a constructive interference, you will have the path difference equal to n lambda. And whenever there is a destructive interference, you will have the path difference of n plus 1 by 2 lambda. So in this case, we are getting the constructive interferences because we are able to see all those fringes. So n lambda equal to the path difference, and the path difference is 2d sine theta. So very simply you can find the interplanar spacing between the two planes. Clear? Just note it down. One more thing which you may find in some books is what are Miller indices. See, calculation of Miller indices is not that important. Suppose if they give you a Miller indices of HKL, for example, I can give you a D111 plane. What does it imply? H equal to 1, K equal to 1, L equal to 1. And I can give you the edge length of a cube, the unit cell which we use. That edge length is A. And I can ask you to find the Miller indices or the interplanar distance DHKL.
What are HKL?
Miller indices. They are just the coordinates. calculation of Miller indices is not in the syllabus of JEE, but you may find it in some books. You have to take the intercept at x-axis, y-axis, z-axis, and then you take the reciprocal of it, and then you take the simplest ratio. And that simplest ratio is known as Miller indices. But that is not in the course of JEE. That's why I'm just writing down the main formula which may be used. Clear? Let's note it down. Now suppose you want to calculate the Miller indices. See, suppose I give you the intercepts as intercept on x-axis as say 1, intercept on y-axis equal to infinity, and intercept on z-axis equal to infinity. What does it imply? What kind of plane it is? If the intercept on x-axis is 1, the intercept on y-axis is infinity, and the intercept on z-axis is infinity. What kind of plane it will be? Intercept on x is this. It will be a plane whose equation will be x equal to 1, or the yz plane, right? And this is x equal to 1. Suppose you have to find the Miller indices for this. So first of all, they will give you a plane. For example, in this I give you a plane whose equation is x equal to 1. So what you have to do is first find the intercept. So the intercept on x-axis is 1, on y-axis is infinity, and z-axis is infinity. So write the intercepts: 1, infinity, infinity, x, y, z. Second thing is take the reciprocal of all these. So reciprocal will be 0, 1, 0, 0. And third thing is take clear fractions. What are clear fractions? Simplest ratios. So in this case, if I take the clear fractions or simplest ratios, it will be 1, 0, 0. So this will be h, this will be k, and this will be l, which will be known as Miller indices. Are we clear now?
Yes, sir.
Clear? Suppose I give you a different question. Suppose the intercepts are 2, 3, 1. This is x-intercept, y-intercept, z-intercept. Find the Miller indices in this case. First find the reciprocal. 1 by 2, 1 by 3, 1. And the clear fractions will be 3, 2, 6. So this will be h, this will be k, and this will be l. Now these are known as Miller indices. So once you find these Miller indices, they can also ask you to find the interplanar spacing d. And they can give you the value of a. So you can say d is equal to a by under root of h square plus k square plus l square. Are we clear? But see, all this is not in the syllabus of JEE. I am just telling you because it is given in some books. So you may get confused at times. Are we clear? So this is the end of solid state.